Okay, we're going to look at some functions today. Look at, first of all, finding minimums and maximums. A minimum is basically the bottom of a valley. It's the lowest point on the function, kind of down at the bottom of a valley. The maximum is the top of a hill. Sometimes you'll have a function like a parabola that has an absolute minimum or maximum. That's the absolute highest or lowest for a point. But we also need to know about relative minimums or local minimums. Like this point right here is a minimum value for this function. And this point right here is also a minimum. I would say this point here at 4, -1 is a local minimum because it's the lowest point of that particular valley. This point over here looks like it might be something close to maybe -1.5, -4. It is also a local minimum because it's the lowest point on that valley, but it is also the absolute minimum. So this one is the lowest for this part of the graph. This one is the lowest for the entire graph. For our purpose today, though, we'll just identify both of them as minimums. Our maximum, we'll do the maxes in green. The maximum I have here is at 2, 0. So when we're talking about a minimum or a maximum, we generally do list the entire point. If you want to read it or put it as a sentence, you would say it has a maximum value of 0. The y-coordinate is the maximum value at x equals 2. So maximum value of 0 at x equals 2. Or you could say it has a minimum value of -1 at x equals 4, or another minimum value of -4 at x equals -1.5. So that tells you how to find minimums and maximums. Go ahead and try to pause the video, try number 2, and then we'll look at those answers. Okay, on number 2, you should have a maximum value over, a minimum, since I've got the blue marker going. I'll do the minimum value first of 1, -2. This is a local minimum. You notice it can get smaller over here, so it's not the absolute minimum for the whole graph, but it is the minimum for that part, 1, -2. And then I have a maximum value over here of -1, 2. And that is once again, that's a local maximum. It's a hilltop, but it's not the maximum of the whole graph because the whole graph can get even taller. But it's still important to know these local maximums and local minimums. Hope that helps you understand that. Now for number 3, we're going to graph those in Desmos. Pause the video and go ahead and graph those in Desmos, and then we'll look at them together. Okay, I have them ready in Desmos. The red graph is f of x. Now notice if in Desmos I click an equation, it gives me lots of gray dots. What I'm looking for here is the maximum. So the maximum would be the hilltop. Be sure you get the correct gray dot. Zoom in if you need to. There's your maximum of 0.08 and an x value of 0.8. So a maximum just above 0 there. The other one, the blue graph, you notice it is for g of x. And this one, I cannot see the maximum, so I might need to zoom out sometimes. And once I zoom out, I can get that maximum. So my maximum there is, might need to zoom back in to be sure I'm on the right thing, because remember, we can get different types of gray dots, and I would want to make sure as I move this graph around that I'm actually on the point that is my maximum. Yep, there's 2 dots really close to each other. This one here, the -2.71, is my intersection of the red and blue line. This one, the -2.667, is the maximum. So it's important to zoom in when you have several of those gray dots that might be close to each other, and make sure you're clicking the right one instead of just looking at it at that other zoom. It looked like there was just one. So clearly the higher maximum is for g of x, and the maximum value is 3.48. So the higher maximum was gx, the maximum was 3.48. Go ahead and try the last one in Desmos, and then we'll look at it. Once again, f of x is my red, g of x is my blue. And in this current zoom, I can't tell much of anything. So remember, I can click my house, my home button, to go back to the default zoom. This problem, we're looking at our minimum value. So the red graph has a minimum right there at 0, 0. The blue graph, on the other hand, has a minimum that's clearly a little bit lower at -0.7, -1.4. So you would say g of x has your smaller minimum, and it has a minimum of -1.41 at x equals -0.7. And remember, if it asks you for the value of the minimum, you use the y-coordinate of -1.4.